Hi, everyone. Our project was the digital energy meter capstone conceived by Bex Walker from Sustainability Department here at SOU. My name is Luke, and I mainly worked on the database, working with Firestore to hold all the information needed for our web app. I also helped with full stack development as well as being the main contact in our group.
My name is Corey, and I primarily worked on the Google Cloud side of the project, making the application into a portable format to upload and connecting up the deployment pipeline to automatically update any changes we make to the publicly accessible side.
My name is Griffin. I worked primarily on the Leaflet.js map main page that will be presented to you shortly, as well as the map and data import and design for said page.
Hi, my name is David. I wrote tests for the dashboard to make sure buttons and other interactable elements work the way they're supposed to. I did web design to match Sustainability's own page, and I worked on implementing the charts you'll see in a few minutes. But before we show the website, I actually want to talk a bit about the background of the project. So Sustainability has been working hard to make our campus more energy efficient, and they've been adding solar panels and electricity meters to our buildings. And right now, we're getting all of this data from the meters, but very few people actually have access to it. And even for the ones who do have access, it's time consuming to parse because it's just columns and rows of numbers. So they came up with this idea of a public electricity dashboard. It takes all the data from the meters, organizes it, and presents it in a way that can be understood at a glance. This benefits sustainability, facility operators, and student research. It will help them work towards a greener campus more efficiently. And at this point, we'd actually like to show off the dashboard, and Griffin is going to introduce it.
This is the main page of the SOU Energy Dashboard web application, and as you can see, the primary focus of this particular page is the map view, which is a big map of all of the buildings on the SOU campus that has each one of the buildings highlighted. Some of these buildings have little solar indicators on them that indicate whether or not they are generating a little bit of solar power for the campus. Now, if we decide to click on one of the buildings here, we can see that a little bit more of the information for that building, including the square footage and the building type, which can inform why it is consuming as much electricity as it is, as well as some of the kilowatt hour consumption for the most recently uploaded month. Additionally, we have a little bit of a chart down here that shows us some of the energy consumption for that building throughout the course of the most recent year. Now we will move on to the Compare Buildings page, which will be introduced by David.
So this is our comparison page. It lets you compare electricity usage and energy efficiency in two different ways. The first way is directly between buildings, and the second way lets you compare a building's current usage against its historical usage. We can start a direct comparison by clicking our calendar, where we can select a time frame for comparisons. Next, we have our filter button here to filter by tag, because many buildings have multiple classifications. This lets us include buildings that would be tagged office, but exclude ones that would be tagged classroom. Finally, we can add some buildings now, and when we add a building, it generates these cool little cards that show us some information, like the building's electricity usage for the selected time period, whether it's solar powered or not, and its EUI, or energy use intensity. And EUI, for those of you who don't know, is a unit of measurement that shows the building's energy efficiency by comparing its usage relative to its size. Finally, the cards also show which buildings are more efficient, which ones are less efficient. Next, we have our little charts here. So each line shows electricity usage over time, with each line representing a building. You can mouse over the points on the graph, and it will tell you the exact amount of usage for that month. Next to it, we have a bar chart that shows each building's EUI for the selected time frame. And below both charts, we have our raw data tables, which is just the data laid out plainly. Now we can look at year-over-year mode, which has many similar features. So with the calendar in this mode, you can only select by year. The filter button works the same. And when you add a building, the only information that changed on the card is that it shows annual usage only. Down here, we have another line chart showing usage over time, but now each line represents a year instead of a building. And next to it, we have our trend chart, which is actually the same data, just ordered chronologically from our oldest to our most recent data point. This is very helpful for seeing how our usage has changed over time. Other than that, we have our EUI bar graphs for each year, and it has its own respective trend chart as well. And again, all charts have their raw data tables beneath them. And that's it for year over year, which really narrowed the focus to a single building at a time. And next is the efficiency tables page, which goes in the opposite direction and lets us look at campus usage more broadly. I'm going to pass it off to Griffin, who will walk us through it.
This is the table view page, which is kind of like an expanded form of the raw data sections on the comparison page. As you can see, it displays pretty plainly the building name, their category, the kilowatt hour consumption, the square footage, and EUI of those buildings. Additionally, you can sort this data by the same filters that comparison buildings has, as well as download the entire data set if you need it for your own research or to be able to inform others of the electricity efficiency of buildings on campus. On top of that, if you scroll all the way down to the bottom of the table that you're looking at, you can actually see the sum total kilowatt hour consumption of all of the buildings with the filters that you've selected. So if we were to go back up here and say, select the greenhouse, just greenhouses, you'll see that the total kilowatt hour usage is now just the total for the kilowatt hour usage for the greenhouse. Now we will be moving on to a secret page that Luke will now introduce for admin users.
Finally, for our last page, we have the admin page, which is hidden on the nav bar because we didn't want anyone finding it very easily. It is protected by Google OAuth, and you will have to sign in using a SOU.edu email. Now this is our admin page. It's basically just a way to edit the data on the back end without actually having to get into the back end, which is very good for users that aren't quite as tech savvy. We have two main ways of uploading data, upload CSV and manual entry. Upload CSV is really important because we get our data dumps every month in the form of a CSV that has the building and how many kilowatts it used that month. So our client is able to just put that file in here and upload all that information in one simple step. Manual entry is also really important though, as not all of the buildings are on the data dump. Our main example of that at the moment is Lithia Pavilion, which doesn't get added. So for manual entry, we're able to add any building. Let's add art building on December 2026, and a big old number that really shouldn't be in there. We also want to uncheck delete data from 3 years ago. That is automatically checked just because our client wanted to ensure that only 3 years of data would be available at any given moment. Let's hit submit, and it'll ask for confirmation, and we'll hit submit, and you'll see successfully inserted a reading into the database. This will take us on to the next one, edit and delete reading. So once again, we'll select art building on December 2026 and look it up, and we'll see that reading that we just entered. So that's going to be art building, and then we can either update it to some new number and hit update, or as we're going to do right now, we can just delete the reading. Once again, it'll show successfully deleted that reading. Continuing on to edit building, this one's probably one of the most powerful in here. It contains all information about a building, such as the name that'll show up on the graph, any of the tables and charts, the square footage, which is used for EUI, the tags, which you can add, remove, or create new ones, the solar array size for buildings that have solar array, as well as context. That's just some additional information for a few buildings that we need it. We also have map coordinates that you can move around or add more to change the shape of the building based on future renovations. Continuing on, we have our Manage Admin page, which currently has a list of all of us on here. This can take in any SOU.edu email and add it to the list of admins, and then anyone on this list will be able to access that. We can also remove any of the admins minus the very, very last person, so there will always at least be one admin who can access this page. Finally, we have our Reset Cache button, which is really important in conjunction with this page. Our web application only pulls from the database one time and stores it in a cache to be more cost efficient. By resetting this cache, we trigger another pull from the database, making all the changes that we've made on this page actually take shape. Overall, the main requirement put forth by our client was a dashboard that improves public transparency of energy usage at SOU. We were able to meet these requirements with the public-facing web application that you've just seen, using tables, charts, and graphs to show data in a way that anyone can understand, no matter their background. On this slide, we have a list of other requirements as well, but we also faced a few challenges to get to this point.
All right, so here are some of the major challenges we faced in our project. The first one that came up was infrastructure questions. Being that our project is working with an SOU department, we figured that it might be possible for us to get our application running on the SOU infrastructure that we have here. However, when we talked to IT in the first couple weeks of our capstone project, we were told no, with the reason that there was a list of requirements that we probably weren't going to be able to meet, and we agreed with them on that front. Then we wanted to see if we could get access to the data, as the electricity meters, other than Lithia, as mentioned earlier, are networked. And thus, if we could get our client access to those meters, she would just be able to run a script and get all the information and have it directly uploaded to the website. However, we were shot down on that front as well. Moving on from that, coming about a month from the end of Capstone, so about a month ago now, bureaucracy got involved because we wanted our project to actually be a thing, actually part of the SOU website. And when we got to that point, IT got involved again and gave us a new list of requirements. Hooray, fun stuff. So, first we'll start with the big one, ADA. The Americans with Disabilities Act has a list of web accessibility requirements that websites need to meet to reach certain degrees of accessibility for people with various disabilities. For us, the standard that we were aiming for gave us 50 specific tasks to achieve, and we hunkered down for 2 weeks and got all of them done. They touched just about every corner of our website, but we made it through. Next up was security. IT had a notable concern about the security of our application and wanted to make sure that we were doing everything we could. So we went as far as we could, above and beyond, to lock down everything that is a reasonable concern by looking at the top 10 web vulnerabilities currently and making sure we were as close to bulletproof for all of them as possible. And finally, a major requirement and challenge we had just in general was cost minimization. We don't want our application to cost anything if that's at all possible. To that end, we had a couple of different things contributing to that. When nobody's touching the application, it scales down to 0 and shuts down, so it just goes to sleep. Then when somebody comes back, it wakes up again. In addition to that, the application only runs mostly on the client's browser instead of on a server backend. And the results of this are that we got the cost down to approximately 54 cents per month, or about $6 a year. Anyways, that's it.
Thank you for your time.